Hello again. In this video we're going to be talking about factoring, and in particular factoring out the greatest common factor. So first let's talk about what a factor is. When we have two or more numbers or variables or algebraic expressions being multiplied, those terms that are being multiplied are called factors. So when I take 3 times 2, 2 is a factor and 3 is a factor of 6. Same thing if I throw in some variables. I could even have algebraic expressions. So if I had something like 2x plus 3 being multiplied by 5y plus 4, this whole expression here inside the parenthesis and this other whole expression, those are factors. They are things being multiplied. And factoring, when we want to factor, that is undoing multiplication. So in these first few examples, we're going to be talking about factoring out the GCF, or the greatest common factor. So that's what GCF stands for. There's a couple different ways that you can do it. One is by factoring each term individually. For example, 16v, I could break down 16 into 2 times 2 times 2 times 2 times v, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And if you forget how to break it down, you could start with a factor tree, right? 16 is 4 times 4, 4 is 2 times 2, and that's where I get these 4 2's. I could do the same thing with the other term, 10. 10 is 2 times 5. And then we say, what do these have in common? They have a 2 in common. So the GCF here is 2, because that's the only thing that they have in common. So the first step is to find the GCF. If I want to factor it out, I take my original expression and divide out that GCF. Remember, factoring is undoing multiplication. How do I undo it? With division. So this is going to be 16v divided by 2, which is 8v, and 10 divided by 2, which is 5. And then the factored form of this original expression, so here's the original, is going to be the GCF times what I had left when I factored it out. These two things need to be equal. They need to be equivalent. So if I distributed that 2 back through, I should get what I started with. So this on the right is the factored form. I can do the same thing in this next example, only now I've got more terms to think about. So if you can't recognize the GCF, you should factor them. If you can just look at all the numbers and say, well, I know that 6 will divide into each one of those. So GCF. 6 is the biggest number that will divide into each term. I also have to consider the variables. So h squared is the smallest exponent, and I have to take that for my greatest common factor. So it sounds kind of counterintuitive that the smallest is the largest factor, but I can't take more than this. I can't say h to the 5th is the greatest common factor, because this doesn't have h to the 5th. It doesn't have 5 h's. So we're always going to be looking at the smallest, and it has to be in all 3 terms here. Notice we didn't take any v's up here because I didn't have any v's with the 10. So it was not a common factor. Common means in both. Now if you can't recognize that 6 was the GCF for the numbers and h squared was the GCF for the variable part, you can always go back to the factoring. So breaking it down, 18 h to the 5th. 18 is the same thing as 2 times 9, and 9 is 3 times 3. And then I had 5 h's, which you can choose to expand out or not. Negative 6 h to the 4th. 6 is 2 times 3, and we have a negative 1 here. And I had 4 h's, 1, 2, 3, 4. And 24, h squared. 24 is the same thing as 6 times 4. So 4 is 2 times 2. 6 is 2 times 3. And then I have two h's. And again, I look at everything they have in common. They have a 2 in common. They all have a 3 in common. And they all have two h's. So again, this is another way to look at it if you're a visual person. So that's where the 6, 2 times 3, and h squared becomes part of our GCF here. So that was step 1. Step 1 is finding the GCF. Step 2 is taking our original expression and undoing that multiplication with division, dividing out 6h squared from each term. So if it helps you, you could write it out as such. So that first term is going to be divided by 6h squared. Second term is going to be divided by 6h squared. And the last term, same thing. I have to divide it out of everything. That's what makes it a common factor. And then the result should be, so 18 divided by 6 is 3. When we deal with the variables, we subtract the exponents. So 5 minus 2 would be 3. Minus 6 divided by 6 goes away. It divides out. And 4 minus 2 would leave me with h squared. 24 divided by 6 is 4. And the h squareds divide out. And so that is the result once we've divided out that common factor. But this is not the factored form. Remember, we have to write the GCF, which was 6h squared, times what was left when we divided out the GCF. And again, it needs to be equivalent to what you started with. So if I distributed this 6h squared back into the parenthesis, I need to get what I started with. That's your check. Go ahead and try the 2 on the right. Alright, now we're looking at this example here on the right. I'm going to start by identifying the GCF. So I look at the coefficients. I say what number divides evenly into all three terms. And that would be 4, right? 4 divides into 20, into 4, and into 12. Sometimes it helps if you look at the smallest coefficient and then decide the factors from there. And then I say, looking at the variables, what's the smallest exponent I see? I see y squared, right? So I have to take the smallest because that's the most I can take from this term. So I have my GCF. Second step, divide it out. I'm going to take that 20y squared, divide it by the GCF. Same thing with the middle term. And same thing with the last term. And see the result. So 20 divided by 4 is 5. The y squareds divide out. Minus 4 divided by 4 is 1. And y cubed divided by y squared would just be y, right? 3 minus 2 is 1. I have 12 divided by 4, which would be 3. And y squared divided by, or sorry, y to the 4th divided by y squared. 4 minus 2 leaves 2, so y squared. In general, we want to write this in descending order. So when we write our final answer, we're going to start with the GCF. So we want the factored form, which would be the GCF times the result once we divide it out. So I'm going to start with the y squared, and then the y, and then the constant, because I want it to be in descending order. That's the standard way to write these. And there you go. Alright, let's look at this next one. So again, the GCF, first, I see 6 and 3 for the coefficients. I know 3 divides into both of those. I look at the variables. I see A and A, the smallest one was A squared, so they both have an A squared, and they both have a B squared. So you have to consider all the variables. I'm going to take that expression and divide out the GCF from each term. And see what's left. So 6 divided by 3 would give me 2. A to the 4th divided by A squared would be A squared, right? 4 minus 2. B squared divided by B squared is 1. In the next term, 3 divided by 3 is 1. A squared divided by A squared is 1. And B squared divided by B squared is 1. So here's a common mistake that I see. A lot of times when everything divides out like that, students want to just drop it. They want it to disappear and say that this is the result once we divide out that common factor. But it's not. Anything divided by itself is 1. So everything divided out here, 3 divided by 3 is 1. It's not 0, so it's not gone. So when I write this in my factored form, I'm going to write my GCF first, and then times that result of 2a squared minus 1. And again, it's a good check on yourself to distribute that back through, and you have to get what you started with. Notice that if we had not written this minus 1, we'd only have these two monomials to multiply, and we would have lost this second term completely. So we have to have minus 1 so that when I distribute, I have negative 1 times that quantity, and I have this term here that I started with. All right, good luck.